In the last lesson, we learned about division with whole number divisors and decimal dividends. In this lesson, we're going to be focusing on dividing decimals as dividends with decimal divisors. Important points that you need to write down are, before dividing by a decimal, we need to change the divisor into a whole number. So that simply said, we can't divide by a decimal unless we use models. So to make it easier for us to do without models, we change the divisor into a whole number. And to do that, we have to multiply the dividend and the divisor by the same power of 10. And before you get overwhelmed and a little bit confused, just hold tight because we're going to do several examples together. And make sure you copy all of this down for your notes. The first problem we're going to do is 14 and 1900ths divided by 2 and 2/10. And what I meant when I said we had to make the divisor into a whole number, remember that's the number we're dividing by, is that we have to get rid of this decimal point. And we do that by just moving it over to the right as many times as we need to get rid of it. And that's the same as doing 2 and 2/10 times 10. If we move it over one place to the right, that's the same as multiplying it by 10. So now that gives our divisor the value of 22. And with 14 and 1900ths, we move the decimal to the same place. We move it over one place to the right, just like we did over in the divisor. So our problem that we did, when I mentioned that we had to multiply by a power of 10, we're doing 14 and 1900ths times 10. And when I did that and I moved the decimal point over, now we have 141 and 9/10. So now our dividend has a new value of 141 and 9/10. So we're going to write our problem over here, our new problem, 141 and 9/10 divided by, and remember we changed our 2.2 into 22, so we have a whole number to work with now. And now we have a normal looking decimal division problem like we learned in the last lesson. So we can go ahead and do the first thing that we had to do, which is bring the decimal point straight up. And now we can see how many times 22 goes into 141, since 22 can't go into 14. 22 can go into 141 6 times, and we'll put the 6 directly over the 1. 22 times 6 is 132. And we borrow to make that 1 and 11. 11 minus 2 is 9. And since we had to regroup, the 4 became a 3. And that is the answer. And we bring down our 9. So now we have to see how many times 22 will go into 99, which is 4. 22 times 4 is 88. And we do our subtraction again. 9 minus 8 is 1. 9 minus 8 is 1. And we end up with a remainder. And remember, with decimal division, we can't have remainders because decimals are already a type of leftover. So in order to continue our problem correctly, we have to extend our dividend by adding a 0, because we can add a 0 without changing the value, and it still gives us another number that we can bring down and work with. So now we've made 110, and we can see how many times 22 will go into 110, which is 5 times. 22 times 5 is 110, and that gave us an exact answer of 6 and 45/100ths. Now what we can do if we're not sure our answer is correct, we can go back to our original problem. This means that when we multiply 2 and 2/10 times 6 and 45/100ths, we should get 14 and 1900ths. So let's go ahead and see if we were close. 6.45 times, and we remember we're going back to our original problem, 2 and 2/10. 5 times 2 is 10. 2 times 4 is 8, and 8 plus 1 is 9. 2 times 6 is 12. And we move over one place, so we have to add 1 0, and we will basically have the same numbers. So we have 2 times 5 is 10. Regroup the 1. 2 times 4 is 8. 8 plus 1 is 9. And 2 times 6 is 12. And we can go ahead and add up our partial products. We have 0. 9 and 0 is 9. 2 and 9 is 11. 1 plus 1 is 2. And 2 plus 2 is 4. And we have 1. And we move over the decimal point 2 places in the top factor, 1 place in the bottom factor, so that means we have to go over 3 places, 1, 2, 3, in our product. And it looks like we have the correct answer. 14 and 190, or 1900ths, is the same as our dividend. Now let's try a problem. Another one together. We have 0 and 63 10,000ths. So that's 0.0063 10,000ths divided by 7,000ths. Now remember, our first goal is to get rid of that decimal point. We move it over 1, 2, 3 places. Moving it over 3 places is multiplying it by 1,000, because anytime you multiply something by 1,000, the decimal point would move over 3 places to the right. So that we're going to show that here. We have 7,000ths times 1,000. And moving the decimal point over 3 places to the right would actually just give us a plain old 7. But we also have to do that in our dividend. We move it over 1, 2, 3 places, or multiply it by 1,000. And that would put the decimal point between the 6 and the 3, which would give us 6 and 3/10. So now we have our new problem we could write, and we'll write it off to the right over here. 6 and 3/10 divided by 7. First thing we have to do is bring up our decimal point. 7 can't go into 6, so it goes into it 0 times, but 7 can go into 63 9 times. 7 times 9 is 63, so our answer is 9/10, and we have no leftovers. We don't have to add anything on to the end. This means that when we have 63 10,000ths divided up into groups of 7,000ths, we will have 9/10. Before we go on, I know that some of you might be confused by the powers of 10 and where are we getting those hundreds and tens at when we multiply to move the decimal. Well, the powers of 10 are tens raised to specific powers. If we just multiply something by 10, that's the same as saying we multiply it by 10 to the first power. When we're talking about dividing decimals, that means we move the decimal point over 1 place to the right. When we multiply a number by 100, that's saying that we multiply it by 10 to the second power. That just means we move the decimal point over 2 places to the right. And finally, when we multiply it by 1,000, that's the same as multiplying it by 10 to the third power, and we move the decimal point over 3 places to the right. So that's how moving our decimal point over to make our divisors whole numbers ties in with powers of 10 and multiplying by thousands, hundreds, and tens. We're going to try a real-life example now. In the U.S., there are 211.1 million internet users. In Spain, however, there are only 19.8 million internet users. How many How many times more internet users does the US have than Spain? Anytime you see how many times more, they're going to divide. Now, I know that a lot of you know that how many more means you're going to subtract, but the addition of the word times in there tells us that we're going to need to divide in this problem. So we'll set up our problem with the amount of US internet users as our dividend, and that was 211.1. And we're going to divide that by Spain's internet users, which was 19 and 8/10. Now remember, the goal is to get this divisor into a whole number. So in order to do that, we have to move our decimal point over one place to the right. And if you look at our notes that we took on the powers of 10, moving it over one place to the right means that we have to multiply it just by 10. So we will do 19 and 8/10 times 10. And in moving the decimal point over one place to the right, that'll give us 198. Since we moved the divisor's decimal point over one place, we move the dividend's decimal point over one place to the right, which means we also multiply that by 10 by doing 211.1 times 10. And in doing that, that gives us 2,111. So we have 2,111 divided by 198. And I know these look like big numbers to work with, but if you think about it and we break it up, 198 can only go into 211 one time since it's so close. And when we do the subtraction, 211 minus 128 is, make this an 11. 11 minus 8 is 3. This became a 0 when we regrouped, and we have to make it into a 10. And this 2 will become a 1. And we'll bring down the 1. 198 can't go into 131 at all, since 198 is larger, so we're going to put that it can go into it 0 times. And 198 times 0 is 0, and we do our subtraction and we end up with 131. That's a really big remainder, and again, remember, we're dealing with decimal points. We can't have a remainder. Decimals are already remainders in themselves because they're parts of a whole. So we have to put in a decimal point, 0. As soon as we put in that decimal point, we have to bring it up so we don't forget about it. And the reason that 2,111, the decimal point goes after it because it's a whole number, and that's the same as 2,111.0. Now we can go ahead and bring down the 0. Now I have to see how many times 198 will go into 1,310, and I'm going to use the guess and check strategy to do this. Off to the side, I'm going to work out a few problems, but I need to think first. 198 is close to 200, and 1,310 is close to 1,000. So I'm going to try 198 times 6 to see what that gets us. 8 times 6 is 48. 9 times 6 is 54, and 54 plus 4 is 58. 6 times 1 is 6, plus 5 is 11. And that gets us pretty close. Let's see what 198 times 7 will get us. 8 times 7 is 56. 7 times 9 is 63, and 63 plus 5 is 68. 7 times 1 is 7, and 7 plus 6 is 13. That took us a little too far, so 6 is our answer. And 198 times 6 is 1,188. When we do our subtraction, we do 10 minus 8 and we get 2. 10 minus 8 is 2. This would become a 2. 2 minus 1 is 1. 1 minus 1 is 0. We get 122 after we do our subtraction, and again, that would be a remainder. So if we wanted to keep going, we would need to keep adding zeros. So we can go ahead, we'll add one more zero and then we'll stop. 198 can go into 1,220 6 times. We already have that worked out over here. And that gets us 1,188. And when we do our subtraction, 10 minus 8 is 2. 11 minus 8 is 3. 1 minus 1 is 0. 1 minus 1 is 0. We have 32 left over, and we're going to go ahead and stop there. So that's 10 and 66 hundredths. And if we wanted to round to the tenths place, we could. The 6 makes the 6 go up to a 7, so that becomes a 7. This is gone, and everything to the left stays the same. So 10.7 is our final answer. So that means if we did 10.7 or 10.66 times 19.8, we would get an answer that's very close to 211.11. So let's go ahead and answer our question that was originally asked in a complete sentence. The question was, how many more times internet users does the US have than Spain? So when we answer that in a complete sentence, we could say that the US has 10.7 or 10 7/10 times as many more internet users than Spain. Finally, on your own, I want you to copy down and solve the following problems. The first one is 0 and 9 hundredths divided by 1 and 8 tenths, 52 divided by 4 tenths, 62 and 4 tenths divided by 2 thousandths, and 5 and 6 tenths divided by 14 thousandths. Make sure you solve each problem using your notes and examples. If you need to ask for help, make sure you do or write down any questions you might have.